Good morning, India, and good afternoon, Malaysia. So, hi everyone. So, today I would like to present our paper with the ID 1001 with the title Grey Oyster Mushroom Classification Toward a Smart Mushroom Grading System for Agricultural Factory, especially in Malaysia. Uh, so, I will talk about several contents over here. The first thing is the introduction. Then I will be discussing on the research problems and the objective afterwards. So then a bit about discussion on the related works, then how we do the data set collection of the images, and I'll be explaining the experiment setting afterwards, and then finally I'll be discuss and show the result that we achieved so far. And yeah, I will be concluding and put some future work over here at the end of this slide. So a bit about introduction about our paper. So basically a visual evaluation of vegetable and fruits helps classification tasks in handling the agricultural product quality, especially on the traditional methods which happen to our Malaysian standard of agriculture, whereby we use the eyes and hand picking. So towards of that, since the evolution of the industrial revolution 4.0, basically the involvement of the computer vision comes into the agricultural sector. So in our country, Malaysia, basically there is a authority organization called Federal Agricultural Marketing Authority, what we call them FAMA. So it's an agricultural organization that propose categorical types for grey oyster by proposing a one standard MS 2020 and 2012, and in that particular standard of grey oyster mushroom, so we have three categories, whereby this is the category number 1, category number 2, and this one is category number 3. So all these categories of grey oyster mushroom are dedicated, which the sizes, colors, patterns, and damage condition. So we can see over here. So speaking of what we have facing right now in the mushroom plantation agricultural activities, so basically the most common thing that we've been adopt until right now is manual eyes observation, whereby the classification is happened by the workers based on the judgment of the one particular workers and the other particular worker. So the majority of the grey mushroom related work research are conducted with the inter-class tasks or a bigger group of mushrooms. So whereby inter doesn't mean that in such particular huge of mushroom type, so we have it's not only grey oyster mushroom, but by classifying other mushroom types. So from this context of research, basically there will be one more things that need to be considered and need to be attention of is the intra-class mushroom study, whereby intra-class meaning that the mushroom itself is studied by the variety of shape, colors, and condition within that particular mushroom categories. So here we focus on grey oyster mushroom. All right. So a bit about the research objective. So by having the three problems that has been tested before, basically we have three research objectives. So we try to introduce and propose the grey oyster mushroom classification via the three classes, focusing on the intra-class classification. So we then design and evaluate a grey oyster mushroom classification by model based on the Malaysian standard MS 2020 and 2013, which has been published by FAMA and also Malaysian standard. So and then we try to analyze the effectiveness of the state-of-the-art VGG16 by utilizing the model to classify the grey oyster mushroom categories that we propose in our paper. So speaking of which, there are many studies has been conducted before, so we can conclude it as two types of study, whereby the multiple study which focusing on the multiple types of mushroom itself, whereby the single is only focusing on this particular mushroom. Okay, so not to forget that we have a kind of limitation on those study whereby we have inter-class, RGB, and etc. So this is the most recent study that has been shown in the grey oyster mushroom. Is we have those that related to the IoT, Internet of Things. So whereby the Rahman and others are doing research on a single types of mushroom, whereby they are using or implementing the Internet of Things, which are related to the RGB image feature. So what we done in this particular proposed paper, basically we did image capturing on the site. So we have a collaboration with the Sina Syukrawit Enterprise. It's located in Alor Gajah in the northern part of Malacca. So we went, one of the authors went there and then captured two types of mushroom, whereby we call it as a ready to be sold or can be sold, or this one is not ready to be sold or cannot be sold. So while this one is the images that taken from or downloaded from the third parties or a public domain, whereby we can use Bing, Google, and so on and so forth. Okay, so these are the environment of the mushroom factory. So speaking of which, we set our experiment to be in several steps. So first of all, we went to the Sina Syukrawit Enterprise for capturing the images. We collect 2 to 3 categories: can be sold, cannot be sold, and others. So that we then arrange the datasets into training, evaluating, and testing by fixing the 80%, 10, and 10. So I did mention before, we use VGG16 for the classification task of the grey oyster mushroom. So we utilize this network as our brain of our system. So we then train and evaluate the VGG, and finally we conclude this performance of grey oyster mushroom classification by using this kind of model. So the experiment setting has been set to be 540 images for the training and evaluate. So the testing images for all these 3 categories are set to be 60 images for training, evaluating, and testing, as we did discuss in the previous slide. And the size of all the images is 224 times 224 pixel, and the experiment was conducted within batch size 6, and we fixed the epoch time as to be 10. Okay, these are the results that we gained through the experiment that we set before. So speaking of the training model loss graph, basically we have this on the left hand side of the figure. So we can see that our evaluate or testing period, we have the orange, while the blue is reflecting to the training performance on the model loss side. Okay, so we just want to focus on the right hand side, model accuracy. So speaking of which, we just focus on the evaluate orange line over here. So whereby the longer that we have, it's not the longer, the more epoch, I think we just consider until 10. So basically the evaluation time shows that the accuracy of our classification rise up, and then there will be a kind of reliable accuracy, I think slightly at 94% over here. So that will be our proposed model accuracy. So based on a bit on the comparison via confusion matrix for the 3 classes of grey oyster mushroom over here, we can conclude that by using the remaining 10% of the total image, which has been stated before as 600 total image, So these are the coefficient metric that we have, we gain. So 3 out of the 20 are estimated as grade B. For the grade A, basically only 3 are not really keen to be classified as A. So for the A tested images, while the B one, we have 2 for A and 1 for C for the targeted B, right? And the C group is almost there, so perfect 20 images was were classified by for category C. So whereby C is illustrated the other categories from can be sold and cannot be sold. Okay, finally, I will be concluding my our paper. So this preliminary study shows that VGG could perform well in the simple classification task. So yeah, we gained 96.7 accuracy in training and 90% almost in the testing stage. So however, the proposed could be extended with the grade 1 for the FAMA grade Oyster, since the FAMA standard which has been proposed in MS 2020 and 2013 reflected to the 3 categories. So whereby now we just focus on the 2 for the initial study of the grey oyster mushroom. So then the dataset images could be extended also, since we need to have the grade A or grade 1 based on the FAMA. So we could extend our dataset images over here. And yeah, so obviously alternative image processing technique is also planned to analyze with the research paper scope for the further research in our future research paper. So overall, as I said, here are still considered to consider as still a small number for having a good but still having a good and reliable classification of via deep learning. So that's all, I think. Thank you for your attention.